So let's start off with the next property of definite integration. And in this one, you have even and odd functions concept. So you just have to make sure that the limits, whenever you try using this property, the limits is the in minus and plus. So like the same number in the lower limit and the same in the upper limit, the only difference will be of sign. So something like minus 1 to 1, minus pi by 2 to pi by 2. So the concept is that if fx is even, if the function is even, then you can write this as 2 times 0 to a fx dx, and if it's odd, then it's equal to 0. So let's see some sums based on this. And before we do that, let's also just understand the concept of even and odd. So what actually happens is, like say if you have a function fx is equal to sine x, right? So if I put, wherever you have x, if I put minus x, so I have this as sine of minus x, and sine of minus x is minus sine x. So actually you find that f of minus x is actually equal to minus of, and this sine x is actually fx. So fx, so I can write this as, so eventually what I can do is I can write this as f of x is equal to minus of f of minus x. So whenever something like this happens, okay, so in that case you will say that the function is odd. This is a odd function. Now what happens in an odd function? So odd functions are symmetric. They are symmetric at origin. So that is also one more way by which you can, identify odd functions. Something like this. Let's say the sine graph. So sine graph is this way, right? This is the graph of sine. So it is symmetric about the origin. So the concept is, if you take the integration here and if you take the integration here, the definite integration. So here you will get negative answer, here you will get positive answer. So it gets nullified. So the answer is eventually 0, right? Similarly, if I talk about even functions. So see, sin x is just one example of odd function. So you have many odd functions. So let's say if fx is equal to x, so that is also odd. Why? Because f of minus x is equal to minus x. Even if you check the graph, so y of x, y equal to x, the graph is this. So here you will have positive, the positive area, and here you'll have negative. So it gets nullified. Okay. Even functions, so something like cos. So fx is equal to cos x, and f of minus x is equal to cos of minus x, which is also equal to cos x. So fx is actually equal to f of minus x. So these are even functions. So symmetric. They are symmetric about y-axis. So something like this. Cos. This is the graph of cos. So here the area and here the area, both are positive. So instead of finding both the areas, what I can do is I can just find this area and I can multiply by 2, right? So this is the concept of even odd functions. So just let's take an example. So let's say the question is, so we have integration minus pi by 4 to pi by 4. So as soon as we see the limits, we understand that we can go ahead and apply the property. And this is sine 4. So, so this is sine raised to 4x x cube dx. Now we need to check whether this is even or odd. So what I'll do is I'll write fx is equal to x cube sine raised to 4x. I'll put, wherever I have x, I'll put minus x. So I have minus x the whole cube sine of raised to 4 minus x. Now minus, this will be minus x cube, and sine raised to 4, it's even power. So this will be sine raised to 4x. Obviously this is equal to minus of f of x. So this is odd function. So I can directly write the answer as 0, right? So just make sure that it's not always that you will get an even or odd function for this question. So let's say if the question is minus, just a example, minus pi by 2 to pi by 2, and if you have log x, let's say this is the question. Now when you check log x, so you'll realize that fx is equal to log x, and f of minus x is equal to log of minus x. Now you cannot take minus outside of log. So this is neither even nor odd. So you have such functions as well. In that case, you will just use any of the methods available to solve the question, and you will not use this property. Okay, let's take one more question. So let's say we have something like this. So we have minus pi by 2 to pi by 2. Let's say we have x square dx. Let's take a very simple example. X square, so obviously this is even, so I can write this as 2 times 0 to pi by 2 x square dx. And now I can just go ahead and integrate. So this is x cube by 3, 0 to pi by 2, and I can get the answer. So hope you like this video, and the properties of definite integration is clear. So till next time, take care and bye bye.